Guys, we're on. We're on and we're starting right now. We are at Algebra 1 Regents. We are at short response section and we are on question number 27. This is going to be part 3, basically, of our Algebra 1 Regents journey. Okay? So let me just go ahead and start question number 27. And if anybody has any questions, you can write it as a direct message to the chat. And I can re-explain. I can answer like an ongoing question. I can repeat the explanation. So basically, anything is on demand. Okay. All right, guys. Let's just start. The function f of x is shown in the table below. Okay, so we have a table. Okay, x, fx. Pretty standard. Okay, so state an appropriate value for m in a table so that f of x remains a function. Remains a function. What do we know about that? Well, we know that in the function, x's cannot repeat. So we have 0, 3, 2, 6, 1, 5, 4. So basically any number other than the numbers on the top. So literally up to you. We can use 7, we can use 8, we can use 10. Doesn't really matter. Let's say 10. I like 10. Okay, so 10 and explain your reasoning. The reasoning will be in order f of x to remain a function, x values must not repeat. And that's good enough an explanation. By the way, you know what? I've got several kind of like reviews of what we of our previous parts of algebra, of this region that we were doing, algebra 1. And what I've heard is that people really like me going over the right and the wrong model response answers in a short response. So let me pull that up and we can discuss the right and the wrong answers and like why and why not people got a full credit or half credit, no credit at all. So here it is. Let's look at it real quick. Number 27. So full credit would be, okay, so 7. 7, like I said, would be an appropriate answer. And why? Okay, so the number 1. Okay, why? Number 1? Oh, the number I. Okay. The number I chose was 7, but any number that isn't already listed in the X section on the table is appropriate. This is because the functions must have a different input. Okay, so yes, that's exactly basically what I have just said, and it makes total sense. Also, score 2. Another score 2, and it is also 7, and it says the input value has to be unique. Very short and very correct. The input, which is x value, has to be unique. Unique means not repeated, not one of those. Okay? This is score 1, guys. 7, so that was correct. Oh, f of x. No, it's x. It's not f of x. Since 7 does not repeat, oh my, look at this, guys. Look at that. So since 7 does not repeat through the x values, it will have to be specific output of 9. If 7 was already in the x value, then it could not have used again. The student wrote a correct explanation. So this explanation is considered to be correct, but since the student wrote f of x and not x, they took away half of the point, even though 7 is kind of correct. So be careful. Okay, and this is also 1, an appropriate value for m on the table. Okay, so guys, you know what? To be honest, I don't want to waste that much time on it. It's kind of like an easy question. 0. 0 because it would go back to the x-axis and go back. Yeah, who's gonna go back, man? All right. Next, number 28. Solve x squared plus 8x equals to 33 for x by completing the square. All right. By completing the square method, we need to know completing square method. And I told that to each one of you that this is gonna come up on the region. So let's just do it. So x squared plus 8x, step 1 would be to put a constant value, which is the one that has no x, on the right side. Guys, by the way, if you don't know how to do completing square method, please write it down as I do it. Just as a practice, you need to know how to do it, and it's really important for the regions, obviously, not for anything else. Okay, so that was step 1, to make sure that the constant number, the regular number with no x, is on the right side. Step 2 is, and here I have a shortcut for you guys, and the shortcut goes like this. If you have not even if you have, you can just create parentheses squared, and inside of those parentheses you put x, and you always put half of the b value plus 4, half of the b value always. So you kind of like keep completing square. Like, let's say you skip the hardest part and go right into the easiest part. The only thing is that you must remember is that you're gonna have to add a square version of that number to the right side too. So we're going to have, so step 3 is to actually like solve whatever is going to be on the right. So it's going to be x plus 4 squared equals to 33 plus 16, which is 49. Step 4, take the square root of both sides. Take the square root of both sides to get rid of that square on the top. So what you're going to get is you're not going to have squared anymore. You're going to have x plus 4, and you're going to have, and here is another thing that you must remember, it's going to be not just 7, because square root of 49 is 7. It's going to be plus minus 7. Don't forget plus minus. Step number 5 is to move the 4 to the right side, or whatever it is, the number that's going to be here. But don't forget that it's going to change its sign. So now it was positive 4 becomes negative 4, plus minus 7. And the kind of last step is to do both of these realities separately. Both of these realities means that negative 4 plus 7, negative 4 minus 7. And it's going to be, in this case, it's going to be 3. In this case, it's going to be negative 11. And those are the answers. This is officially the solutions to this quadratic equation. All right. Just like I said, it's going to be, well, x, shortcut half of the number, adding square root of both sides, move the number to the right, don't forget plus minus, and then add and subtract. Okay. Next question, guys. Next question. If f of x equals to negative 3x minus 5 over 2, algebraically determine the value of x when f of x equals to negative 22. All right, let's do it. All we have to do is to equal it to negative 22. If f of x equals to negative 22, just put in negative 22 instead of the fx. So let's actually just do that. Negative 22 equals to negative 3x minus 5 over 2. So step 1 to solve that would be multiply both sides by 2 to get rid of the fraction. So it's going to be negative 44 equals to negative 3x minus 5. Step 2 is to add 5 to both sides. It's going to be negative 39 equals to negative 3x. Final step, divide by negative 3 both sides. And it's going to be x equals to positive 13. That's it. That's it, guys. Yeah, I'm not gonna go over the wrong answers here because this is just a technicality that we're gonna have to just solve. Moving on. Rationalize the denominator of the fraction below. Express the solution in simplest form. What does that mean, rationalize? It means, in plain simple words, it means get rid of the square root or radical, if you want to say, from the denominator. That's what means rationalize. What is the trick here? The trick is to multiply top and the bottom by square root of 2, like that. Why? Well, on the top, nothing will change for now. It's 4 square root of 2. But we do it so it will change on the bottom. Square root of 2 times square root of 2 is square root of 4, which is just a regular 2. And now we can reduce 4 and 2 by 2 by just dividing them, like reducing them, simplifying, I would say. So it's going to be no fraction anymore. On the top, we have 2 and then square root of 2 next to it left. This is it. That's the answer. There is nothing more, nothing less. Just multiply top and the bottom by square root of 2 and like get rid of the square root in the denominator. That's it. All right. We're moving on and we're moving to the next question. Alex had $1.70 in nickels and dimes on his desk. There were 25 coins in all. Write a system of equations that could be used to determine both the number of nickels and the number of dimes D that Alex had. Use your system of equations to algebraically determine both the number of nickels and the number of dimes that he has. So basically, we have to create a system of equations and then solve it. Let's do it. The first system that we create is about how many coins there are. It says 25 coins, right? And that's exactly what we're going to do. We're going to say N for nickels plus D for dimes equals to 25. The amount of nickels and amount of dimes equals to 25. The second equation is going to be about money. So how it's going to go? It's going to be, since nickel is $0.05 or 5 cents, it's going to go with N. Plus dimes is 10 cents. So let's just go ahead and put 10 with a D. And together they're going to add up to $1.70. And this is it. This is a system of equations. Two equations, well, which one equation about the number of coins and another about the dollar value. Okay, and now we have to solve it algebraically. Okay, so let me copy down the system and then I will show you what will be an easier way to do it. It's doable on the calculator, by the way, but they say algebraically. So algebraically means that you're not allowed to use a calculator to just find the answer. Otherwise, we'll find the intersection. The first step, what I would do is to get rid of the decimals in the second equation. How can I do that? If you noticed, all of them have 2 digits after the decimal point. Let me zoom it in. So if I multiply the bottom equation by 100, all of them will turn into, like, this will turn into 5, this will turn into 10, this will turn into 170. So let's do that. So it's going to be n plus d equals to 25. No changes there. And then 5n plus, you know what? I wish I could actually write it right under. 5n plus 10d equals to 170. Now we can use an elimination method. So how I'm going to use the elimination method? I'm going to multiply the top equation by a negative 5. Why? This red like on a, you know, kind of on the well, while everything is like in black, it looks so satisfying. Okay, so why did I do that? So that this n will become negative 5n. Negative 5n minus 5d, and what I'm doing this, equals to negative 125. The bottom equation, I'm just copying. 5n plus 10d equals to 170. Now I'm combining like terms, and I'm going to eliminate the n's, and I'm going to have 5d equals to 45, which means that when I'm going to divide by 5, I'm going to get d equals to 9. If I have d equals to 9, I can go back. So there are 9 dimes. That's what it means, 9 dimes. So if there are 9 dimes and the total amount of coins is 25, it means that the nickel would be 16. There's 16 nickels in and 9 dimes. So maybe I would even write it, you know, because I don't know, if you already solved it, just write it. So like 9 nickels and 16. Oh no, my bad. 9 dimes and 16 nickels, because n equals to 16 and n stands for nickels, and 9 dimes, and that is the answer. Again, highlights of the problem. The highlights of the problem is actually it's not that hard of a problem. Usually this problem worth 6 points. This time it's a 4-point question. Guys, 4 points is already a lot. So knowing how to solve a question like that is extremely useful. Now, both of these equations are made based on two different things. How many coins? And don't forget to use n for nickels and d for dimes. So how many? Nickels plus dimes, 25. 25 coins. How much money is that? 0.05. Well, I hope you know that nickel is a 5 cents. If you don't, I don't even know. You know, maybe you'll be able to ask your teacher. I doubt you'll be able to ask a teacher. Yeah. So you need to know that nickels is like 5 cents. So 5 cents, 10 cents with a D equals to $1.70. And then solving, actually, I would even think it's almost as easy as just make a system. But solving, we already have been practicing all together. So I hope that it helps, and I think it does. Good old systems and systemware problems. All right, guys, moving on. Question number 32. Question number 32 is a 4-point classic question. What do I mean by saying classic? I mean, I see the words linear regression, and right away, I know that it's a linear regression question that we all do on the calculator. On your graphing calculator, we are going to input these values for x, these values for y, press a couple of buttons, and then it will give you the exact answer. It's the easiest 4 points that you can get. So correlation coefficient will actually go with the, so that's what I'm going to do. I'm going to show you how to do it during our next class, like with whoever it's going to be. I'm going to show you how to do it is just, I'll borrow, because I don't have the program that has like a graphing calculator here. So I'll just, now that I borrow, I'll just actually use my own graphing calculator to show you how to solve this live, because I need to show you like which buttons to press. But it's very easy. It's one of the easiest 4 points you can score on the Algebra 1 Regents, and it's like a must-know type of thing. I had students who passed Algebra 1 Regents just by knowing how to do this well. A couple of other questions, they're like high value in points questions, and they passed the test without like obviously you're all studying, but I'm just saying that knowing this is a must thingy, because it's free points. It's literally like you press the buttons, it's literally there. They literally tell you like what would be the equation, what will be the correlation coefficient, and what is it? State the correlation coefficient, and then how to determine what is the correlation coefficient like says about that problem. Okay? So this is a problem that we will do in our live class. All right. We're moving on to number 33. Oh, look at this, guys. A second problem with a quadratic equation. Now we have to solve it using quadratic formula. There was a completing square one, and now there's one with a quadratic formula. So if you don't know quadratic formula, don't panic. It's there. It's given. It's right in front of you. Say thank you. That you don't have to memorize it. Now, copy it down into your question, which is negative b plus minus square root of b squared minus 4ac over 2a. Now, I don't know why I'm writing with that lovely teal color. All right, I'm going to switch to black like all of a sudden. All right, so you need to know what A, what B, and what C is. So the number in front of the x squared is A. Since there is nothing, it's 1. B will be positive 4, and C will be a negative 3. A, B, C. And all we have to do is just to plug them into this formula. So let's go. Negative b, which will give us negative 4 plus minus square root 4 squared minus 4 times 1 times negative 3. And it's all over 2 times 1. Let's just do the calculations. Negative 4 plus minus square root 4 squared is 16. Negative 4 times 1 is negative 4 times negative 3 is plus 12 over, now negative 4 plus minus square root of 28 over 2. Now you need to know what to do here. So now you will need to split it in two fractions. So one fraction will be negative 4 plus minus, no, actually, let's do just plus over here. Negative 4 plus, and then we have to simplify, by the way, we can do it on the side, simplify the square root of 28 by breaking this into square root of 4 and square root of 7. If you don't know how to break down radicals, ask me during our next live class. So it's going to be 2, and it's going to be square root of 7. All right, so it's going to be negative 4 plus 2 square root of 7 over, you know what, guys? Let me go back and just say this answer can be written with just plus minus. The only thing that you need to do is just to write 2 square root of 7 over 2. Divide everything by 2. What I mean everything, I mean 4, 2, and 2. You can divide by 2 to simplify it. So it's going to be negative 2 plus minus nothing, which nothing means 1. Like, we're not going to write 1 square root of 7, just square root of 7. Although if you put 1 here, I don't know if they're going to take it. And it's going to be over 1, so we don't even need a fraction. This is the final answer. This is the final answer. 2, negative 2 plus minus square root of 7. I'm not going to write 1. It's silly. All right. This is the second question that has to do something with quadratics in this test. So quadratics is the must-know thing that we're going to have to learn really well. All right. Question number 34. Guess what? It involves quadratic. Surprise, surprise. What do we do here? We have, and it's that we have to solve algebraically, so we can't just put it in the calculator. So I want to switch to blue. Okay, so what are we going to have to do? We're going to use something that's called substitution. Oh no, I don't want that thin. Substitution. What are we going to substitute where? We're going to take that quadratic, since it equals to y, and we're going to substitute that y with our quadratic. So how it's going to look like? It's going to be x squared minus 7x plus 12 equals to 2x minus 6. This went there instead of that y. Now we're going to have to make sure it equals to 0, because that's how we solve quadratics. How? By getting rid of the 2x, and right away by getting rid of that negative 6 by adding it to the both sides. Now what we're having is x squared minus 9x plus 18 equals to 0. All right. Now we have a quadratic. Now we can solve that quadratic. How can we solve it? Quadratic formula, completing square, and something that's called factoring. This is the easiest way, the fastest way, I would say. We have to find two numbers that multiply to 18 and add to negative 9. So what multiplies to 18? 1 and 18, 2 and 9, 3 and 6. What we're going to use is 3 and 6, because these two numbers can produce negative 9. So it's going to be negative 3 and negative 6, because negative 3 plus negative 6 is negative 9. Negative 3 times negative 6 is positive 18. Then we equal these parentheses separately to 0. But in reality, just getting opposite signs of the numbers that we just got, 3 and 6. That's not over though. These are just, like, since we're looking for coordinates of the intersection, like, imagine we have a parabola and we have a line, right? They usually intersect at 2 points. What we just found the x coordinates, but we need to find y coordinates. So we found 3 and 6 as x, but we need to find the y's. How? Easy. Just take that 3 and then 6 after it and plug it into one of the original equations, like let's say into this one because it's easier. Y equals 2x minus 6. Y equals 2x minus 6. Plug it in for x and calculate. I'm going to do it with red. Y equals 2 times 3 minus 6. Y equals to 6 minus 6. Y equals to 0. So this is 0. Okay? And then the second one we're going to plug in is 6. Is going to be y equals to 2 times 6 minus 6. Y equals to 12 minus 6. Y equals to 6. And the second one will be 6, 6. So that is the answers. 3, 0 and 6, 6. Okay? This is how it's done. It's also a 4-point question and very doable. We're going to do a lot of that in our preparation, just generally. This is something that we're going to train doing a lot. A lot. All right, guys, let's see if we can. So, oh, look at this. This is a 6-point question. Basically, the final boss of Algebra 1 Regents. let's take a deep breath and do it. What color do you want to defeat this final boss with? Orange. So my favorite color. That is probably more orange than that one. All right. Enough with the colors. Let's just go ahead and fight it. Anna plans to spend $30 on balloons and party hats for her daughter's birthday, including the tax. Balloons cost $2 and each. So balloons $2. And party hats cost $1.50 each. The number of party hats Anna needs is twice as many as the number of balloons. If X represents the number of balloons and Y represents the number of party hats, write a system of equations that can be used to represent this situation. All right. So let's see. First, just like in the system before we solved today, it's going to be about the number and it's going to be about the price. About the number is going to be Y equals to the number of party hats. So then they say the number of party hats Anna needs is twice as many as the number of balloons. So balloons has to be equal, like it's basically like this. For one party hat, you have 2 balloons. So that's why Y will equal to 2x. So in order to equal them, balloons need help of times 2. That's the best way I probably can explain. Now, the second equation, so this is already, that's it. That's the first equation. The second equation is going to be about the price, just like with those nickels and dimes. And it's going to be like this. So balloons cost $2 each. So balloons is the X. So it's going to be 2x. Party hats cost $1.50 each. So plus $1.50 times Y, and it equals to $30. And this is it. This is the created system. All right. And now we have to most likely just graph it, right? Graph the system of equations, the set below. It's 2 lines that we're going to have to graph. So Y equals 2x is pretty easy to graph. All we're going to have to do, you know what, I'm going to do it here. Why not? This one, I'm going to do Y equals 2x. And this one, I'm going to do, on this one, I'm going to do 2x plus 150, Y equals to 30. All right, so t-table. I like doing t-tables. All right, so if x is a 0 in the first one, by plugging in 0 here, I'm going to get 2 times 0, which is 0. If my x is 1, and I plug in 1 there, it's going to be 2. Y will be 2. And I can make as many points as I want, but I only need 2. I need 2. I don't need more. All right, so if you're going to be pretty neat, this is all you need. 0, 0, and 1, 2. 0, 0 is here. 1, 2 is there. And then you just connect it, right? Like all the way. Now, so you can continue. You could have like done 2, 4, right? You just keep the slope and go up. Now, don't forget to label it, I guess, you know, just in case. Some teachers who check that, they really want you to label. All right, now the next one is going to be, like, I also can use a t-table here, and in this case, I like using zeros a lot. Like, let's say 0 for x, right? If I plug in 0 there, it's going to be 2 times 0, which is 0, and then it will say 150y equals to 30, right? And when you're going to divide both sides by 150, you'll find and it's going to be 20. Now, you can use 0 again, but not for x. You can use 0 for y. And now if you plug in 0 there, it's going to be 2x equals 30, which where you divide by 2 is going to be 15. So 0, 20, 0, 20, oh, all the way. And 15-0. 15-0. And then you can connect it. Like you need a ruler to do it, but like no, I won't be able to do it with a mouse for sure. Something like that. State the coordinates of the point of intersection. Guys, in order to get the accurate points of intersection, you just need to do it neatly and it will be obvious what would be the point of intersection. So I guess let's just see what it is. Look at that. Look at that. What is this? What is this? Okay, those are probably wrong answers, right? I hope so. Yeah, this is score 3. This is a 6-point question, guys. Don't forget. All right. 6-12. Do I have something close to 6-12? Guys, I think I have exactly 6-12. I did it without a ruler. 6-12. Explain what each coordinate means in the context of the problem. So if she buys 6 balloons, she can buy 12 party hats. So let's see the answer. Full credit one. Okay, let's read it. The solution is 6-12 in the context of the problem. This means that for 6 balloons and 12 party hats, the name and we'll have be able to pay for the supplies as well as have twice the amount. Okay, so this is a little bit extra, I guess, but pretty much exactly what I said. Let's see another one. This was score 6. So what is score? Oh, this is score 5. Score 5 has a wrong one of the graphs wrong. Although I don't know. Oh, this is just some lucky stuff because the person kind of got the correct the correct intersection point even though having a wrong line. This is crazy luck. Okay. The student did not label at least one of the lines. Look at this, guys. I told you that you need to like label them like this. And I think the next one was not labeled at all. And a point has been taken. 6-12. So what does it say again about this answer? It says that the student did not label at least one of the lines of the graph, and their explanation was incorrect. Incorrect explanation. For every balloon, the number of party hats doubles by the amount of balloons. Nah. Score 4. All right, guys. This is... I hoped it would be funny answers, but they're just like wrong. Wrong. So this is it. That means that for 6 balloons and 12 party hats, Anna will have to be able to pay for the supplies as well as twice the amount of balloons. Okay, so I wouldn't phrase like that, but this is also not that bad. Guys, this last question was very, very doable. And look at this. Look at this region. They did 2 systems and they did two quadratic equations, like two quadratic equations, just straight up quadratic equations, solved by completing squares, solved by quadratic formula. One system they had when you had to solve algebraically, and 2 systems that you had to create and solve, like one algebraically and one on the graph. So systems and quadratics, I guess that's the theme. If you would know 2 things, systems and quadratics, well, you're passing this test. You're even scoring a decent amount of points because there is a lot of quadratics and systems also, like in a multiple choice. So I guess this is what we're gonna have to push and study more of. But for now, this is it. We're done. And next class, I'll see you all live and we'll continue our journey. So everyone, have a good night.